Okay, today's maths lesson is to use the ladder method to do multiplication. Now, over the last few lessons, the last lesson we've done online and the ones we did at the end of last term, we were doing the grid method. We're now going to do another method called the ladder method. Now, in many ways, the ladder method is easier than the grid method. So you might be thinking, well, why did we have to learn the grid method in the first place if the ladder method is easier? And the reason is that the grid method shows you why it works because it makes you partition the number first. The ladder method does not make you partition the number first, but it does make it easy to add it up afterwards. So without further ado, let's have a go. So we've just been doing the grid method. So in the grid method, we would actually have to partition this number here into 900, 20, and 5. We would times it by 7. Then I normally start with the ones number. I do this for reasons that will become important in later methods, but it's a good habit to get into. So I do 7 times 5, 35. And I will do 7 times 20. This is like 7 times 2, 14, but 10 times bigger, 140. And then I'll do 7 times 9, which is 63, but then it's 100 times bigger. Okay, we have these extra zeros we've had to add in as placeholders because one number was 10 times bigger and one number was 100 times bigger. We then need to add these bits up, and we basically, well, in this case, we don't need a column addition to do it, but we could use one. Am I writing a 9 there? 6,300, 140, and 35. 0 add 0 add 5 is 5. 0 add 4 add 3 is 4, 5, 6, 7. 3 and 1 is 4, and then 6 on its own is 6. 6,475. We need to actually go back and write it by the question. Okay, that method was good. I like this method because it made you show me that you knew that 925 was 920 and 5. You had to partition it. But what a lot of people didn't do in their work, and where nearly all the mistakes I saw when marking it came from, were in this bit here, not doing the column. Now what that means is you end up with 2 written methods to solve one question. It's good for you mentally because it makes you partition the number, but slower on paper. So let's have a look at a different method. Let's do the same question again. This time it's going to be a bit like a ladder, lots of steps going downwards. So the first thing we do is write the first number in. It's 925, and we're going to times it by 7. Now, the book that you're going to do the work from tells you to start with a hundreds number. I think this is silly. We're going to start with the ones number. Okay, 7 times 5 is 35, and 35 goes in there. Now the next one, 2 times 7 is 14, but this isn't a 2. This is a 20. Even though this time we haven't written it out as 20, and that's why before I made you do it, we need to still remember that this is a 20. So our answer isn't 2 times 7 is 14, it's 20 times 7 is 140. And then we have 9 times 7, but it isn't 9 times 7, it's actually 900 times 7. We need to remember that. 9 times 7 is 63. But this is 100 times bigger, 2 extra zeros. It's 63 moved twice. It's 6,300. Oh, excuse me. So 6,300, well, now we get to add them up. Now what we've got here is very nice column addition already laid out for us. 5 add 0 add 0 is 5. 3 add 4 add 0 is 4, 5, 6, 7. 1 and 3 is 4, and 6 is 6. It gives us the same answer, but it does it all in one go. It's easier to make mistakes because you can forget that that 9 it's actually a 900, and you forget that that 2 is actually a 20. Now, you can kind of cheat here, because this number will always end in a 0, because a multiple of 10 times anything will always end in a 0, and this will always end in 2 zeros. Because a multiple of 100 times something will always end in 2 zeros, unless it's a decimal, but we're not doing decimals, so we'll just ignore those. So what you can do is go and draw these in before you start. Be wary, because some numbers will end up with another 0 and don't think you've already done them. So let's have a look. So I'm going to cheat, and I'm going to write my zeros in here, ready to go. Now back 253 times 5. Right, 3 times 5 is 15. 5 5s are 25. And I'm writing it there because I've already got my 0, because actually it's 50 times 5 is 250. 2 5s are 10. Now, do not do that thinking, well, there's a 10. No, 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 no. No, 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 no. Whoops, rubber. Rubber, please. Oops, that's too big. No. The problem we have there is the 10 goes here. Because this 0 here is part of our 2 placeholders. It's because we had 10 and moved it twice over. So be very careful. By all means, draw in your zeros to begin with, but then make sure that you do put the numbers in the right places. So let's add this up. 5 add 0 is 0 is 5. 5 add 1 is 6. 2 is 2, and 1 is 1. 1,265. Okay? We'll do a couple more as examples, but the principle of this isn't hard. If you A, know your times tables, B can add up afterwards. And don't make a mistake with these zeros. So again, let's be a bit cheeky and naughty. Put these zeros in now, because they're going to be there. 526 times 4. 4 times 6. Well, 4 6s are 24. 2 6s are 12, and 24 is that doubled. 2 4s are 8, but it's actually 80, but I've already got the 0 in there. And 5 4s are 20. It's actually 2000, but I've already got 2 zeros in there. 4 add nothing is 4. 2 add 8 is 10. 0 add 1 is 1. And 2 is 2. 2104. Right, one last example. 7, 2, 5 times 2. I'm going to go back to my green pen because I think it made it clearer. Put in my placeholders because they are definitely going to be there. Right, 2 times 5 is 10. 2 times 2 is 4. 2 times 7 is 14. 0 add 0 add 0 is 0. 1 add 4 is 5. 4 is 4. 1 is 1. 1,450. And there we go. That's all there is to it. There's another example in the book, but like I said, the book makes you put that bit at the top and that bit at the bottom, and I disagree with that. So I want you to put the ones calculation there, the tens calculation there, and the hundreds calculation there, please. Don't forget, this is a video. If you want to watch those again, you can literally rewind it and watch those 4 calculations again. Now, this is work you are going to do. There's a lot of multiplications here. There's 12 on the first page and 9 on the second page. Frankly, if you can do quite a few of those, if you've done 7, 8, 9 of them, if you've done 4, 5, 6 of them and got them all right, you probably know how to do it. So there's a lot of questions here. We'll call this level 1, we'll call this level 2, and we'll call this level 3. The only bit that's physically harder is this level 3 here because it goes into worded problems. So my suggestion with these is, if you think this is going to be pretty easy, start on the level 2, just do the level 2s and then do the level 3s. If you're not sure, start on the level 1s where some of the calculations are slightly smaller, but don't necessarily do all of them. Check a few, perhaps do a few from here, and if you're happy with them, then you can move on. If you want to do the worded questions, you can. If not, you can just do some from the first page, the red box and the blue box. I think at least 10 questions that are just plain multiplications is good, and then maybe move on to some worded problems if you can. Now, something which I did not remind you about last lesson, but really should have. If you have done a worded question, I would like to have a worded answer, please. So even if you've written out all of your lovely working and you found the answer, I would like you to give me an answer. I would like you to write it as a sentence. So it's the first one says, Clive has 3 planks of wood. Each plank is 478 millimeters long. He puts them end to end. How long are they all together? I don't just want a number. I want to have Clive's pieces of wood are something all together. And also remember units. If it's in millimeters, give me an answer in millimeters or centimeters. If it's in sheep, give me an answer in sheep. Oh no, not in sheep, sorry, it's in legs, isn't it? Give me an answer in legs. This one's in paper clips, so tell me how many paper clips. This one's in kilometers, give me an answer in kilometers. This one is in bottles, give me an answer in bottles. This one's in money, give me an answer in money. And again, it starts off in pence, but if it ends up in hundreds of pence, pounds is probably a better unit to give me. Like I said before, I don't agree with this. I suggest you swap those two round. Now, one thing I didn't think I'd have to say, as last lesson was a lesson on the grid method, was to show me your working. A couple of people gave me lovely pieces of work with all the correct answers, but absolutely no working. So a piece of work on the grid method had no grid methods in it. Now, I don't know how those answers appeared. They were questions that I couldn't necessarily have done in my head. Now, I'm going to be optimistic here and say that no one just used a calculator, wrote down the answers and sent it in to me because they wanted to get on with doing something else. I really hope that wasn't the case. But I need to see your working. This is a lesson on ladder method. Please show me ladder methods. At least 10 questions, maybe some worded questions, maybe more if you're into it, maybe more if you got a few wrong and you want to check it. By all means, use a calculator to check your work afterwards, but show me your working and give me sentences for the worded questions, please. If you've got any questions at all, you can always ask Miss Rumpf or myself. Okay, good luck and have fun.